All right, welcome back. Before we begin, today obviously is the last lecture for this semester. So that's good news. We made it finally. So yeah, so today is the last lecture, and I just wanted to cover a few topics that are like the recent trends in ML and AI, and like point you to like emerging research areas if you're interested, let's say in future or right now, you can explore those. I also wanted you to I wanted you to explore some of the important research papers in each of these fields. So I have like provided links to those as well. But before that, a quick announcement about the project presentation. So I saw everybody's uh, preferences, but then everybody's preference was on Friday, which obviously is something that's like not doable. So I randomly picked like teams and assigned them, and also keeping their preferences in mind. So what we can do, yeah, hi. So let me just repeat what I was saying. So about the project presentations, everybody's preference was Friday, but so obviously I have to randomly assign, but also keep the preferences in mind. So there are 3 teams on Tuesday and 3 teams on Friday. And you can check the Excel, the link, like which team is presenting what day. And if like you have any issues with that, because I just like numbered every team and just like put them in a random number generator. That's how I did it. So in case like you have any issues in presenting, especially the teams that are presenting on Tuesday, just let me know, just like drop in an email and maybe you'll figure out. But keep in mind that not everybody can present on Friday because it's like almost impossible. Even if we are keeping like 15 minutes for each presentation and then like 5 minutes for questions, then 6 teams cannot present like in 1 hour, 50 minutes. So that's that. And in addition to that, if you're presenting on Tuesday and there is something that remains and you still need to work on that and like submit your final report on Friday because it's due on Friday, you can do that. Just like even during the presentation, you can just like let us know that this is the part that you're still working on and like what is the progress and so on. So that shouldn't like stop you from presenting on Tuesday. Any questions about project presentations? Just like people who are joining now, I saw many of you just joined online. So please check the project presentation schedule once more. I have randomly assigned teams to Tuesday and Friday. So based on that, you'll be doing your presentation. Now, in terms of the logistics side of things, how to do your presentation, because that question has come up many times. It's totally up to you. If you have a Jupyter notebook and you want to present on that, I'm absolutely okay with that, as long as you can describe your like what the problem that you were solving and like how you solved it, what are the resources you used, and what are the results you're getting. You can use a PowerPoint presentation, and that's also okay. Now, the way you can present it is either you can send me your presentation and use my computer to present here, or you can bring your computer. And if you're more comfortable doing that, that's also okay. There are many students who said they'll be presenting online, and that's also fine. I can share, like I can be on WebEx and I can share my screen and like you can present. So all these 3 options are available. Whichever works better for you, that's fine. I would highly recommend that each member from the team presents some part, at least pointing like what their contribution to the project was, because that will help me grade better and easier, because then I'll have to like go back and forth and ask you like who did what. So like if during the presentation you can make it somehow evident, then that would be helpful. But regardless, like if you don't want to explicitly do I did this and I did that, that's also fine. Make sure that everybody like contributes to the presentation in some ways. Okay. Any questions about the project presentation schedule? And if you have questions, feel free to post on the discussion forum. I'll keep checking that, especially over the weekend, because like if something new comes up, just post it there and I'll try to answer as soon as I can. Okay, Sean, your question. Yeah, I can repeat that. If you go and check the link that I sent to put your preferences, I have assigned teams to different days. And I did that like randomly. So I literally like wrote a single line of code and put like every team in there and just like randomly assigned it to Tuesday and Friday. So you can check like which team is presenting what day. Obviously, like everybody wanted to present on Friday. That's impossible. And so I had to assign like three each. Okay, yeah. Other questions? Anything? Okay, so that's okay. That's fine. Welcome to lecture 25. So believe it or not, this is the last lecture and we made it. Yay. So yeah, so today's lecture is just about like pointing you to the current and future trends in AI and ML research, what is happening now. And these trends are with respect to what you see in the conferences and what you see in the application side of things. I've also pointed you to some important papers in like every subfield of AI. If you're interested in that area, definitely go and look at what's going on in because like the recent research papers are a must, especially if you're interested in like working in this field because every day new things are coming up and every like if you just go to Google Scholar and search for a particular topic in AI, you will see how many new papers you'll see almost every day. So this field is rapidly changing and we need to be familiar with what's going on. And if we are like interested in the field of like the application side of things as well as like the research side of things, the top trends are something that we should keep like be in touch with. All right, so top AI and ML research trends in these fields, NLP, conversational AI, computer vision, reinforcement learning, information retrieval and recommender systems, and then a quick look at what auto ML is. I'm pretty sure that you must have come across that term auto ML, and that is being repeatedly used in a lot of publications on a lot of platforms. And so we'll see like what exactly that is. So beginning with natural language processing or NLP, throughout the semester, we have been like working with different AI models and machine learning models, and you've implemented a lot of them, worked with like real world data and implemented these models. So you do understand quite a lot about like different types of models. Like at least you understand the architecture and the working of some basic AI models. But NLP mostly has been like using sequence to sequence modeling, so RNN, LSTMs, DRUs, and so you're familiar with all that. Now, the recent trend in natural language processing has been these pre-trained language models. And we have talked a little bit about these, like some, um, okay, so word to vec and glove are these like existing word embeddings, if you remember. So word embeddings were different from what we were doing with a bag of words model, just a reminder, because it's no more or less like a single vector where you're just like saying, okay, this word exists, and so 1 and a 0, but rather they take contextual information into account. And remember, we said that for every word, there is a vector that represents that word. And because like for any language, it takes a lot of time to train this from scratch. And so we already have these pre-trained models from like a huge like database of text and other information. And then we can use these to, and like there is a step of adaptation, obviously. We can use these to apply to some new problem, to our problem, to use with other labeled data, and sometimes even with unlabeled data. Right, so the focus of NLP is pre-training and fine-tuning. Those are the two keywords right now. And there has been a lot in addition to word to vec and glove. There have been like other more complex models in this field, for example, Elmo and BERT, specifically BERT. So you'll see that name a lot. So it's a bi-directional uh, uh, sequence to sequence model in the sense that it is trying to learn embeddings for sentences, and it's taking their context like both forward and backward. So this is like a more complex model as such because it's not taking the words and creating embeddings, but like whole sentences as context and both like forward and backward and like where the word appears and how many times the word and other like aspects of the word, and then creating a more complex model. So more like towards using BERT, you will see people are more focusing towards these bi-directional models to capture better context and culture and other things pertaining to the language in which like this model is trained. So I think I had a very nice. Okay, so this is like the first trend. I'll go to the papers as well, where like one of them describes how to use BERT. Um, Other such transfer learning models are this OpenAI GPT-1, GPT-2. We discussed a little bit about these, but not in detail, but most likely you're familiar with them. And then this Albert is like a light version of BERT because BERT is known to be like very I wouldn't say inefficient, but it takes up a lot of resources if you're trying to use it. And so the like an alternate to that is this Albert model, which is lighter in the sense that it creates some embeddings that can be already generated and saved and then utilized. So like even faster way of using BERT. So another trend, uh, generally speaking, in NLP has been to incorporate linguistics and knowledge in NLP, meaning um, linguistics meaning bringing in human experts and like taking their knowledge and their output and their like annotations and then embedding them in somehow in these models. So that's like again to improve like the performance and the interpretability of the data driven approach. That's like this one, right? So that's another recent trend. And then finally, this neural machine translation. And we'll see like one article that talks about all of these three in detail. So let's actually go here, right? So this is a very good, in fact, it has been adopted from this tutorial from this conference. So there is this like entire tutorial which like has been posted here. And this talks in detail about what's happening in transfer learning in NLP and how this is proceeding forward and what are the areas that you will see a lot of research and application going forward in NLP. So this is how the tutorial is organized. So let's quickly go. So we understand transfer learning is a means to extract knowledge from a source and then apply it somewhere else. And like we minimize the need to train and retrain. So this is what this thing is pointing us to. And let's say this shows how this has like grown like tremendously over the past few years, I would say. And every month, every 2 to 3 months, we have a new, a more improved version of these like pre-trained models that makes the applications of NLP even easier and faster and more accurate. So that's why there is like there is a, I would say, a huge explosion in the number of like these transfer learning models that are out there. So yeah, so this actually summarizes what types of models do we have right now. So transfer learning can be divided into two parts. The way like the utilization or the usage of these models can be divided or split into two parts. So one is transductive transfer learning and inductive. So basically, in this one, you have the same task as the pre-trained model. So there is nothing new. But the label data you're using is the same as the source domains. There was some domain from where the like this text came from, and then the task at hand is like very similar to that. But sometimes the task is very different from like how this data was collected and how these models were pre-trained, right? So then you need to do more essentially than just like taking the model and using it. So there are like basically two branches. And yeah, I wouldn't go into too much detail here. We have seen sequential transfer learning a lot. So most of the models are using this sequential transfer learning. Um, yeah, so this has seen the biggest improvement so far. I would agree with that. Because if we even look at the BERT model, it is a sequential model, except that it's like bidirectional, of course. But yeah, the adoption in most of the applications has by far been the most for the sequence transfer learning or sequential transfer learning. Okay, so this is a must-read article, and I would say like it summarizes the emerging frontiers in NLP really well, and it points to some of the important papers as well. So you can see the links all over. If you're interested in any of these, like converting from words to words in text, or modeling, language model pre-training, using deep networks in NLP, like there are these relevant papers that you can explore. All right. This link, if you go to this one, so this one, the first one, the first link is talking about BERT and how we can use it like the entire NLP pipeline. How can BERT be utilized to solve actual like real world problems and how it stacks up against other models that are there. So this one was, BERT was actually developed by Google Research. So that's here it's just like a sort of a demonstration of how it can be utilized. And so this paper is like I think an important one in the sense it came out in 2019 and it captures uh, the not just the performance of BERT, but how it stacks up against other models that exist. So that's the first one. But the second link is like really interesting. It talks about all like at least 10 to 12, and for some reason it sometimes doesn't open for me. I don't know. But this is a very nice, yeah. It talks about at least 11 different research papers in NLP over the last couple of years, and also give a nice like overview or a summary of each of these papers. So I was interested in this like Albert, a light bird for self-supervised learning language representation. And you will see this term self-supervised learning a lot in language models and in NLP, meaning that we are moving towards more unsupervised learning models in some sense. So there are some models that are unsupervised and they're achieving like really good results. But regardless, this Albert is a light, I would say, addition, a lighter version of BERT because it has two things: factorized embedding parameterization. So again, a method where the size of the hidden layers is separated from the size of the embeddings. So basically, some decomposition is done to make it faster, like in short. And again, some parameter sharing is done so that like you can get rid of a number of computations. So that makes it faster. Yeah, so some of the achievements of this model are 89% accuracy on a lot of, like this is a benchmark model. And then again, this score on Glue benchmark. So basically it achieved really good results, even compared to some of the benchmark models and compared to BERT. So this has seen like a huge adoption in the field of NLP, Albert. All right, so this link has at least 10 to 12 papers. And if you're interested in any of the emerging NLP areas, you should definitely go and read a few of those. All right, so the second thing that we're looking at is conversational AI. So I'm pretty sure you're familiar with that. It's Alexa, Google Home. So any like those form a part of conversational AI, but like more like the rapid, I would say, adoption of conversational AI has been with chatbots mostly. So if you just like go to any new website, you see that window coming up, and then like they have like these set of questions that they ask about the platform, why you're there, more information from your end, and they keep giving you some information. So earlier, how the chatbots used to function was that there is like this, you can have some rules that are set up that like you know that this is the kind of person who's going to come up on this platform, and so this is the kind of questions that you can ask and so on. But now they are AI powered in the sense that they can go beyond those already saved set of questions and come up with some intelligent and more conversation-like questions with the users. There has been like a huge increase in the number of like AI-powered chatbots. And obviously, these use natural language processing and machine learning to better understand what the human is saying in order to provide a more natural answer. And there has been a great improvement in these systems. And I would say the main focus of conversational AI and the development of that has been in dialogue systems. So dialogue systems are nothing but doing a more human-like conversation with like a user coming in. And also like many research teams address like the diversity of machine generated responses. Emotion recognition has seen a huge improvement. So I'll show you what dialogue systems are. And so there are like three important research papers that I just put them there. Let's look at this one. So this is like some kind of a dialogue system, as you can see here. So the user comes in and says, I'm looking for a cheap restaurant in the center of the city. And so these type of like rather a dialogue rather than like asking a direct question, right? So there's a difference there, and the AI-powered chatbot needs to not just understand the context of like what's going on, but also give a reply that's useful for the user, and that has like some meaning there, right? So the way this like happens is that the system answers there's a cheap Chinese restaurant called Dojo Noodle Bar, and then the user like again says something about it and so on. So there is like a proper human-like conversation going on. So it's not just like you have some rule-based chatbot sitting there and then you have some certain set of questions that the user can pick from, but it's like a more free-flowing conversation, and so you need more intelligent systems there. So there has been a huge, I would say, humongous rise in the number of these dialogue systems in this conversational AI field. More because, yeah, they are like needed in a lot of applications. You see it on your phone, you see it in your car, they're almost everywhere, right? So this particular paper actually has uh, created this model called TRADE. So this is transferable dialogue state generator. So obviously, I'm not going into the details of this. If you're interested, you should definitely go and read it. The whole idea is that this transferable dialogue state generator would not be specific to a particular application or a particular type of a website. For example, this model will not be only applicable to, let's say, a restaurant, but you can also take it to some other type of a business, and most likely it should learn and it should be able to have a conversation with the customer. So that's the idea. Like, it shouldn't be restricted to certain like rule-based chatbots that are usually out there. Like, depending on, let's say if a chatbot was installed like a few years ago, if it's there on a restaurant, then you know the certain set of questions. Okay, what is the menu? Are you open? Like, they're like pretty closed questions. And now, like, we are looking for more of like an open-ended questions, or like dialogues or sentences, and not just like a known question. So that's the focus for conversational AI. I think there was a very nice paper about. Okay, this one, they did a study. They experimented with some known models in this one, some known dialogue models. And what they did was, in the input, they created some kind of perturbation, so some kind of noise, and then compared what happens, because you never know what the user is going to ask. There could be a lot of noise in the input. There could be a lot of um, like unexpected inputs and unexpected sentences. Then what happens? And so they did an empirical study here, kind of compare different models. What happens if we increase the noise? Which models work better than the others? So this is like a nice kind of exhaustive study of all the models together. So that's why I put that link there. And then the final one, yeah, so this is a completely different model. This one, it does not use, first of all, any kind of like existing or known models that are there in conversational AI, but it like creates this jointly optimizing diversity and relevance in, like, this is also known as neural response generation. So here is like a good, I would say, demonstration of like what this model does. So here it is like it has a more unsupervised learning type approach for every input. And so it's like kind of classifying what all inputs the model can receive. And then based on that, it generates like new dialogues, right? So again, high level, you should go inside and check what's going on, because it's not that simple. And then obviously what they say, the authors argue, is that like the context of any sentence itself can help you like create this latent space for different outputs, or for like different responses that the AI system can generate, right? So basically you can create some kind of a pre-trained latent space based on the context of a word or a sentence, and then keep generating dialogues from that latent space, essentially. All right, so that's about conversational AI. Obviously, I'm not going too much into the details of these, because these are, like, as I said, emerging fields. As long as you understand the basics, as long as you understand the known algorithms in each of these fields, most likely, if you go and start reading these papers, in some time, you will start getting the idea of like what's going on. And also, like, if you're interested in the future going in this field, definitely keep reading papers, because this field is something that's like emerging every day. So it's never like, okay, I have a knowledge of, like, let's say RNNs, and so that's it in language model. But that's not the case. Like, they are growing every day. There is some new addition to LSTMs. There's some addition to GRUs. There's some addition to these embeddings, the word embeddings, and so on. Right. So this is something that you should like keep a habit of going forward. All right. So the third important application of AI and machine learning is, of course, computer vision. And we had a chance to look at some, like a very small side of computer vision, in the sense that we familiarized ourselves with CNNs. And so now let's see how CNNs are being used to, or like computer vision as a field has been used or is being used in research and like other industrial applications. And obviously, I would say computer vision is revolutionizing this like industries, business functions, and has found successful applications in healthcare, security, transportation, retail, banking, and so on. So there is a wide adoption of computer vision as such. There are a lot of interesting, I would say, trending topics. One of them is like this 3D projections of like from 2D images do a 3D projection, and then eventually try to like find interesting things about like real world objects, and maybe create some like virtual 3D objects. And um, if that's like a lot of I would say tech companies like Google and Facebook have been like really active in that field. So that's like one emerging topic. The other one is the unsupervised learning methods in I would say computer vision. And if you go to this like conference, if you just like Google, this is a no like one of the top computer vision conferences. If you go there and you search for unsupervised learning methods or unsupervised learning techniques in computer vision, you'll see like a whole lot of over the past 3 to 4 years, like a huge increase in that. And that is because, yeah, they're using a lot of already existing models to utilize the newly like generated data and like do something with it. And then the most important thing that I would say, and like I'll show you one of the papers, is computer vision research being combined with NLP. So for example, let's say in a video, generating those captions, or like in a in many, I think there's a nice paper that actually shows that. Okay, not this one. Yeah, here. So creating like these different maybe tags or different descriptions of these images, maybe sometimes. And also like in a moving like video, taking like the attributes of a video and then generating these captions or the description of those like scenes or like in a video essentially. So there has been a rise in that research of late a lot. So this is like one demonstration. What can happen? Let's say in a video you see like these. Let's say now this is an example of a still picture, but if you see more recent papers like in 2020 and 2021, you will see how videos are used to create embeddings based on their attributes. And then a moving video is utilized to generate these like language, for example, let's say English sentences describing it or saying something about it. So that has been, I would say, the focus of like last 2 years in computer vision. And so this is just like demonstrating that how these different tags or these different descriptions have been generated looking at the pictures. So how exactly are these models working? So the way they're working is that just like you were doing with words, you're picking the words and creating some embeddings. So a similar sort of approach is applied here. You pick a video, and obviously it's more computational intensive. So there are like some specific techniques that help do that. But then you pick a video, you take the attributes. Of course, they're going to be pixels. They're going to be other like attributes. You apply some model to that, create embeddings, and then utilize those embeddings to generate these like descriptions. So there is like a combination of both CNNs and language models or like NLP in certain sense. So these are like very complex applications, but yes, there has been a rise in that. So for example, this particular one, why I put this paper here is because they're using a reinforcement learning approach, which is different from what like the usual usually people have been modeling. So usually there is a straightforward deep learning approach where you're combining CNNs with NLP. But here they've like gone even further and they're using reinforcement learning to do this kind of like vision language navigation. So yeah, this is like a right word for this. Vision language navigation sometimes, because let's say in a video you're moving, you're navigating somewhere, and so you're generating captions about like a commentary of that in some ways, right? So those kind of applications. And this one they're using reinforcement learning approach, which is like obviously more complex, but their argument is that the same thing that like other algorithms are achieving, they can do it more efficiently with less amount of data. because like we have a reinforcement learning agent there. Okay, so in another, this one, yeah, this was interesting because they're trying to use some, again, a combination of NLP and CNN by just looking at the attributes and the way the light falls. Like, so this is a very interesting paper because they're studying the pattern of the way the light falls on a picture and like taking the intricacies of that and then generating some like a tag or something with those pictures. So that's why I thought like I'll just still put it there if you're interested in these. Okay, and I totally understand that if like a lot of this would seem abstract in a lot of sense because it is, honestly. I mean, I work in like recommender systems. So if I go into like computer visions and NLP, like most of the things are like, why are they doing it? I mean, this is like so complex. But yeah, like you are seeing, like you'll see that there has been a wide adoption of these things all around. So yeah, the computer vision specifically is like growing at a really rapid pace. So yeah. The last one, so the second last one that I wanted to look at is reinforcement learning. Now, in our lectures during like when we were discussing reinforcement learning, we saw a lot of like reinforcement learning algorithms being used in gaming platforms, and then also on platforms where they were trying to compare human versus AI level performance when playing certain games, right? However, reinforcement learning has not been adopted as much in businesses yet because there still needs to be like, because this is a completely different paradigm of learning. We are not, this is not supervised, this is not like unsupervised. In some sense, you have an agent and then you have this environment, and then the agent is learning from the environment and they might get penalized or they might get rewarded. That's the fundamental idea. So in a lot of situations, this, like when the agent gets penalized, can create dangerous situations, right? So it cannot be applied everywhere. And in many cases, it has been seen that like, okay, so the people are anticipating that like, or it's the expectation from reinforcement learning is that eventually we'll have like this artificial general intelligence, meaning reinforcement learning agents will in some time be as intelligent as humans, or at least almost as intelligent as humans. And so there is a lot of research going on in that area. But the adoption in like real world businesses and applications has been slow because of the very fact that like when you're training the algorithm itself, it needs to be both penalized and rewarded, and then eventually it learns over the course of like some time. And so it needs all that data, it needs all those, the information of all those states, right? So it's a lot like state dependent, if you remember, like from our discussion of reinforcement learning. However, I would say like even before I look at the trending topics, I would say the largest adoption of reinforcement learning algorithms has been in recommender systems. And reason being that if you think about what a recommender system algorithm does, for example, you go on Netflix, right? So you will select or reject an item like a movie, obviously. And this reinforcement learning algorithm is your recommender. So let's say they recommended you 10 movies, you did not select anything. And so it got penalized because obviously you did not select anything. But the cost of that is not huge. I mean, it's not like, of course, it learned with that one observation. And then next time, maybe it will recommend you something else. But then the cost wasn't like a human life or something like that, right? So the adoption has been huge in, like, for example, showing you ads on different platforms, right? You might click, you might not click. If you don't click, okay, that's a penalty. If you clicked, that's a reward. But then, yeah, it's faster. It has a lot of data on these platforms, and so it can learn. Because thinking about how these algorithms learn, they learn online. So that term has been associated with reinforcement learning. But not all applications allow that online learning. Look at medical like applications. It's really difficult to give that like penalty situation to like a reinforcement learning algorithm so that it can learn that, right? So that's why it has not been adopted as much, but yes, it has been widely used in recommender systems. So some of the trending topics are multi-agent reinforcement learning. This is new, and again, this is being used in video games. because usually in video games what happens is that you don't have one agent that's taking decisions, that you might have like more than one agent taking decisions, and that's impacting the environment, right? So in that case, like, it's really useful there, and people have seen some good results out there. And of course, if that can be adopted to some like real world applications, that's good, because like in every environment there are more than one agents that are taking some decisions, and then the environment is like giving them some reward or penalty. Now the problem becomes more complex. Then let's say there are two agents, and both agents have their own set of actions, right? And they're working in the same environment, and the same environment gives them different rewards and different penalties. So in that sense, it's difficult to just keep track of those states, because remember, like in most of them, we were finding the expectation of the summation of all the rewards and all the penalties. And so over a course of time, that is a difficult thing to do if you have like multiple agents. But then again, it's a trending topic because it most likely will find usage in a lot of different areas. The other thing is this off policy evaluation. And many people have recognized it as this being very important for reinforcement learning applications. As I said, reinforcement learning algorithms mostly like are trained online, because like the agent comes in the environment, it's either getting a penalty or a reward, and based on that, it updates like its state and its actions, right? So like most of the algorithms should be like, many of the algorithms have been developed where you can do some kind of an off policy evaluation, meaning it's not like continuously getting data, but you trained it and then you put it in the actual environment. So a lot of like new research has been coming up in that. And many people are saying that maybe that is the future of reinforcement learning applications, instead of like starting from scratch and letting the agent learn there. Maybe we can like do some kind of off-policy evaluation. Exploration and exploitation. So again, a lot is going there in studying that trade-off, because it hasn't been as much studied as the bias variance or the approximation generalization sort of trade-off in other areas of machine learning and AI, like for example, in supervised learning and unsupervised learning. So here, exploration is also an area where a lot of progress can be like achieved, and still you'll see a lot of papers coming out in that particular domain. Here I just like pointed to research papers, and one of them is like, and this is, I wouldn't say that I wanted to focus only on tree-based methods, but I just wanted to show you that there has been a surge in these different techniques where people are combining supervised learning algorithms with reinforcement learning algorithms. So this is one of them. This is just one of them where like they're combining tree search-based methods or models with reinforcement. And there you'll see a lot of like other unsupervised learning algorithms being combined with reinforcement learning. So that's why I have this one here. And I think I have one more that talks about maybe multi-agent. Okay, so this one here is just like a tutorial that kind of summarizes everything in reinforcement learning. It talks about what are some of the issues, for example, like this off policy thing in online training, and like it requires so much data, why the adoption has been so slow, and what are the other research areas that people still need to explore and haven't been explored. So if you go through this one, this actually points to, and this was in 2020, so it's a very recent one. So this can give you a good idea of like where to go from here. And so let's say you're interested in doing some reinforcement learning research. This also points you to some open problems and gives you perspectives on like how to get started on that. So that's why I put this one here. Yeah, and I would say like generally speaking, healthcare is one area that where like there has been a very slow or like almost negligible adoption of reinforcement learning. Yeah, close it. Okay, so finally coming to recommender systems. And there is like a surge in this area, obviously, because recommender systems are almost everywhere. So you can think of recommender systems as being like these new search algorithms. Because now nobody really goes, if you think about your everyday on like these different platforms, you don't go and explicitly search, but it's the recommendations that you're getting. Based on that, you usually pick an item. So like we're moving more and more towards that like a scenario where you go on a platform and most likely you should already have items that you will most likely buy. So basically saying that these recommender system algorithms should become so intelligent and that they are able to predict with higher accuracy what the user is usually looking for based on a lot of their for example, let's say you go on Amazon based on your purchase history, based on your browsing history, and like other transactions, they can figure out this is the next item maybe you can buy, right? So there has been a growth in recommender systems. They are everywhere, and moreover, like high level, the use of traditional recommender systems like collaborative filtering, content-based filtering is not seen as much. And there has been like a huge, I would say, explosion in deep learning based recommender systems. So what like they do, these deep learning based recommender systems, and I don't have them here because all of these papers talk about them. They are like the starting point for all these models. But just to give you an overview of what these do is that we have like user information and we have item information. And until now in recommender systems, we were matching those, right? So maybe you were finding a dot product between them, some kind of similarity essentially. And then you're saying, okay, this item is very similar to this user, and so recommend this. But now we are creating embeddings of user information and we are creating embeddings of item information because especially for user information, we need that. Like on a platform like YouTube, right? You have so much information about the user, the last 50 videos they watched, what their search history was. And so using all that data, I can create these user embeddings and represent my user in a lower dimensional space. That user is a vector, but it's a dense vector because I have more information about this user, right? And so I already have these embeddings with me, and so it's easier to recommend what next video this person is going to like or watch. And so based on that, I can recommend easily. Right? So that's the fundamental idea behind these deep recommender systems. All right, so the trending topics are CNN-based recommender systems. And here is like this DeepCon, which is like this link is to the paper that talks about DeepCon. It's using two CNN models and it's extracting user behavior and item properties from review text. So you go on Amazon, you write a review about some item, and there is a picture of that item available as well. So these CNNs, as I said, here we are interested in creating these dense embeddings for users using some neural network. And that neural network is nothing but like two parallel CNNs. And so you'll see a lot of like CNNs being used everywhere. Why? Because we have image data, we have text data, we have voice data. And so neural networks can process that faster and better. And so using the results of neural networks, we can recommend better. Well, that's the idea here. And then this automatic recommendation technology, it's again like based on the similar principles, learning resources with convolution neural networks. And this is talking about e-learning resources for platforms like Udemy and Coursera, like these educational platforms, where they recommend like what next course you should like take, or like what study material do you need to like improve in a certain area and so on, right? So these are like, again, you will see a lot of new papers coming in where they are talking about deep learning approaches and e-learning resources and how to make recommendations there. So that's the second one. And I would say like these two are pretty much similar to the CNN-based recommender systems, except that they're using like different approaches. For example, this one is used for audio and video clips, how they should be, like how the recommendation should happen on platforms like any music recommender model or like a platform like YouTube. So here, CNNs are used to extract features from music signals, which is slightly different from like the sequential modeling approach. And then they like utilize this to extract features, and then content-based models are used to. So essentially, you will have this. You will not have the cold start problem with this type of a model. That's what they're saying. Why? Because you'll already have extracted some information. How should I explain it? Let's say like there are these like music clips, right? So there are these audio clips. And so you have extracted some features from these audio clips, right? And then a new user comes in. So the cold start problem is, what is this user going to like? All I know is like some properties of this user, like some attributes of this user. But based on the extracted features from those music clips, I can match this better as compared to what it used to be earlier when we weren't like in a position to say like what this user might like. So basically saying that you can extract some low level features of both the user and these audio clips, and you can match them better in that lower dimensional space. So in some ways, it's helping us resolve the cold start problem, because in a cold start problem, I was explicitly seeing, okay, this is a new user. And usually how am I able to make recommendation? Well, look at their previous, like what they were listening and then recommend. But now that's not the case. You can just like based on the properties of the video or the audio itself, recommend them something. Because like depending on where they exist in that latent space that we have created. So that's the high level idea. Uh, okay, this one is an interesting paper, this fourth one, collaborative deep metric learning for video understanding. Again, it's extracting some features, but basically it's using ResNet, if you remember, like the huge, humongous CNN, like where we had like multiple CNNs, but it was like jumping and skipping some of the models or like some of the layers and then like training based on that. So we did talk about it. I wouldn't bring that back, but we discussed that in like when we were discussing CNNs. So here, like ResNet is used to come up with like this collaborative filtering model. And finally, so this is a new addition to recommender systems. That's the reciprocal recommender systems, where we are not recommending like items to users, but we are recommending people to people. So for example, on a dating website, right? Or on a job website where like you're matching to or some like candidate with a recruiter, or like platforms where any peer-to-peer model, right? So for example, there is this like educational platform where you're matching tutors and students. And so that's a reciprocal recommender system. Why is it a reciprocal recommender system? Because an item doesn't have preferences, but a user has preferences. And so because I'm matching one user with another, both users have preferences. And so I have to take care of both of the preferences and then make a match. So for example, on a dating website, I need to know the preferences of both the users and then only I should match. Otherwise, it's not that just like one person has this kind of preferences and there are these items available that I'm going to match. So it's that. And so this makes this problem a little more difficult. And again, deep learning comes to our rescue. And there are many like new models, but one I would definitely like to point to is the latent factor model. And this is another recent paper. And they're doing a very like interesting approach. And so that's why I wanted to figure this out here. Okay, so let's say this is like a dating website. And usually what we do in user item recommendation is that we have that matrix where we get some values for like how similar these users are, or like what is the latent factor for like a particular user for and a particular item, right? So now because we need preferences for both the like female, let's say, so what they have done is that they have assumed that we are trying to match female users with male users. And this is for a dating website, and they're using a dating website data as well. So here they've created two matrices. R1 is like female users and their preferences for male users, and then male users and their preferences for female users. And then they do like a singular value decomposition. So we've seen this happens in model-based collaborative filtering. And you get two different outcomes for like female to male, but male to female. So now what they do is that they combine these scores for every user, and based on like some aggregate values, so that aggregation function has been defined here. So there are different ways of defining aggregation operators. It could be the mean of different values. It could be the harmonic mean or like a simple average and so on. So like these three, geometric mean, arithmetic mean, or harmonic mean. And based on that, they're like estimating preferences of like female for male, male for female. So when like once you have those aggregate values, then you see which ones are like based on their preferences, which ones are close, and then you like go and recommend one to another. So this is like one of the most widely used techniques in reciprocal recommender system when you're treating like one static and the other one whose preferences you're looking at, and then the other one static, and the other one's preferences you're looking at. But then definitely there needs to be a lot of research in this area, given that we need a more dynamic way of like learning these preferences rather than like the way it is done now. But this has given like really good results. This one, yes. Exactly. Yeah, this can be. But the thing is, like with if let's say instead of like male users and female users, you have items, then you don't really care of like going the other way and looking at the item preferences, right? But yeah, like if there was some like other human to human kind of recommendation, then I think this is more useful, right? Yeah, and then there's another intricacy to these kind of problems, like in an item to item, like a user to item recommendation. As we said, like what Amazon has done is that items don't change too much, right? So they already create these item embeddings and they just like save them, and so item-based collaborative filtering is that. So it's like less, I would say, computational intensive in the sense that you already have those, and you don't have to update them as much. But in this case, you do have to update them, and like. Uh, Based on the user's activity on the website and their different like preferences change over a period of time, right? So those kind of things. So this is like a more difficult problem to solve than a user to item recommendation. Okay, so these are some of the important, I would say, trending topics for AI and ML research. I quickly wanted to touch like what automated machine learning or auto ML is, because that has been like one of the buzzwords around. So that's why I thought I'll just quickly talk about this a little bit. And so auto ML is actually nothing but automating this entire machine learning process. Now you've been doing that for quite a while with all your projects. You take like raw data and then you do some kind of a data pre-processing using that, and then you select the model based on the problem that you're solving. You do hyperparameter tuning, and then even like after you've implemented your model, validated it, and then tested it, many times you see that there is something that's not like what you expected, and then you go back and do the entire process again. So basically, like from the perspective of like somebody who's doing data science or machine learning, those are the steps that you need to do or perform, right? So what auto ML is doing is that it's trying to automate this entire process of data pre-processing, model selection, modeling hyperparameters, model compression parameters, and so on. So this entire flow of things is in some ways automated in the sense that there is this like larger algorithm that does all that for you. So if you go to like, for example, AWS, there are certain tools where you just like select the algorithm, select the data set, and that's about it. It's going to show you by tuning like these parameters that like for these values of these hyperparameters, you get this result. So yeah, and this auto ML models are being created for people who do not need to know the theory and the underlying process of machine learning and data science as such, but they should be able to use these models regardless. Like let's say in their business or in their like some other application, they should be able to use it. So again, there has been another like parallel discussion around auto ML that do we in future like even need data scientists and machine learning practitioners? So I think like everybody can have their own perspective on that, but you still need mathematicians, despite like AI being uh, AI doing like so many things. You still need people who understand the maths behind it and then take it a step forward. So I don't think that's hurting us in any way as a community. And so yeah, that's good. If like there is a more higher level of adoption in different areas, that's good for us, I feel. So yeah, it's a good thing. I think auto ML, it's not a bad thing. But yeah, everybody has their own perspective. So. All right, so just to conclude, because this is the last lecture of the semester, and so just thinking about what is the future of AI, there are like different views, there are different opinions about this. Of course, AI is transforming the way we live, and like as opposed to what we were doing like 10 years ago, maybe, and more and more visible around us, as you can see, like in your mobile phones, or like it's slowly coming into our daily lives every day, right? There is something or the other that's like AI powered. If you go to like some website just to buy things, it is AI powered in some sense. So there is like this again, a parallel discussion around will it like take away all the jobs or not. And so, yes, some of the repetitive jobs might be taken over, but then it's also creating new opportunities in many areas. So maybe like ensuring that new jobs are created for employees, reskill them for more innovative jobs. Yes, that's the downside, but then there is like this like larger goal of making life better and easier, like for everyone. And there is this whole area of research, and I've pointed you to this link and this source where you can check. There is this thing known as existential risk from AI. So many scientists and many people in the industry and like research side have kind of predicted and hypothesized that substantial progress in AI could someday result in human extinction, because if we create AI that's smarter than us, then most likely they will end human life or like result in some kind of a disaster that would like, because if the idea is that like as we are progressing towards more intelligent systems, can AI surpass human intelligence? And if at all they can, the whole idea of human existence on this planet is because humans are the most intelligent beings on earth, and that's why they have like a greater control of things on earth. But what happens if we have like a smarter being out there? So yeah, I mean, I don't see I'm like qualified to comment on this because we are like in the middle of I don't know, like there's so much happening, there's a lot of change, but yeah, I mean, I am like a huge supporter of AI. So I don't know. Let's see how things go. But yeah, that's also like another side to AI, and there has been some recent work on that as well. Existential risk. Well, yeah. Okay, so that's all that I wanted to cover in like this semester. That's it. And thank you so much, everyone, for being patient with me. And yeah, just a quick reminder, everyone, please fill out the evaluations so that I know how to improve, how to take it forward. So that's going to be like really helpful for me. If you can just take out 5 minutes and fill that. Let me quickly think. Yeah, that's all. That's it. Any questions? Anything that you wanted to ask about anything else as well? People who are online, anything? Okay, then thank you so much, everyone. And we begin the project presentations on Tuesday. Most likely, I will send out tonight. I'll send out a reminder about that, and also like the details of like how I expect the presentation, everything. So yeah, tonight I'll do that. If you have questions, feel free to ask on the discussion forum or email me if there is something that you want to discuss before the presentation. Yeah, so that's all I have from my end. Yeah, thank you so much, everyone.